What's up? What's up? It's your man, Jimmy Chan. All right, so let's talk about Venn diagrams. All right, so first I gotta explain to you guys what a universal set is. A universal set is everything that's gonna be inside that box, everything in the universe. A is only gonna be a part of that. And the A with that little dash on top, that's considered the complement of a set, which means not in the set of A. And we'll get into more detail down the road here, but let's do this. Let's pretend that I'm going to create a universal set of just the numbers from 1 to 10. Okay? So those are only numbers that you understand as 1 through 10. And let's say set A is the numbers 4, 5, and 6. All right. So what is not in A? So if I was to say, hey, what is not A, right? So if you look at this, a couple of things you can do. One is that you can bring down the universal set, which was 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? You can bring that down and you go, okay, what is an A? A has 4, A has 5, and A has 6, okay? So those are the numbers that A has. That means the rest of the numbers that are here are known as not A, okay? So, in other words, these elements here, each of these elements you do not find in A. So that's what not A means, okay? So if I was to put this in a diagram, if you look here, you will see that A, which is this little circle right here, has the contents of 4, 5, and 6. The universal set has 1, 2, 3, 7, 8, 9, and 10. Okay? So again, this whole box, everything inside this box has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So the universal set means this whole thing. All right? Now, if I say not A, well, not A would be everything that's outside of this circle. Okay? So again, let me do it this way. So here is everything that is A. So everything inside this circle is everything that has to do with A. Everything outside the circle, it would be considered not A. Okay, so let me go ahead and do this. Okay, so everything in gray would be not A. The universal set is this whole thing. Okay, so just because it looks like the not A is the universal set, is not. It's only part of it. Okay, so both of them together, the gray and the red, together would make the universal set. So please be careful with that and not mix them with each other. All right? All right, so I'm going to be consistent with the universal set and the set A here. I'm going to bring that down, and let's talk about disjoint sets. Disjoint sets means that set A and set B have no elements in common. So if I was to write set B would have to be something like, I don't know, 8, 9, and 10, right? Now, I'm just choosing those numbers just because I'm giving you examples here, okay? So in this case, if I was to put this in here, my A is 4, 5, and 6. My B has 8, 9, and 10. What's not in those two will be the rest of the numbers. So it'll be the universal set has 1, let's go 1, 2, 3, and has 7, right? Okay, so this way I still have those 10 elements as a universal set, which is, again, the whole thing, right? The whole box, everything in it, right? So the 1, 2, 3, 4 is not A and it's not B, right? And you notice that none of the elements in A, there's no 4, no 5, no 6 in B, and there's no 8, 9, or 10 in A. So they have no elements that actually are together, okay? So let's take a look. What if I asked you about not A? Well, the not A is still going to be exactly the same as above. So what's not A? Well, A is 4, 5, 6, so the rest of the other numbers must not be A. So 1, 2, 3, 7, 8, 9, and 10. How about not B? Well, not B would be 1, 2, 3, 4, 5, 6, 7. Those would be not B, right? So again, they're different, but notice how consistent the not A has been because I'm keeping the same thing there, okay? All right, let's talk about a proper subset. So a proper subset is saying that, okay, so here's my universal set. I have A, but for a proper subset, all the element of A are in set B. So B would be something like this. Meaning that everything in A is in B, but all of B doesn't have to be in A. So if I was to draw this, again, I usually draw from the smallest to the largest, so I would go with the A first, which is 4, 5, and 6. Now, don't forget, this right here is in this blue circle. So it's part of it, right? And this is A. And the blue here is a B. And what else is left? Well, there's 3 and 7 left. So if you look at everything in here, right? Everything in this blue, you're going to have 3, 4, 5, 6, and 7, right? Not just the 3 and 7, but all of it. While the red here has 4, 5, and 6. Okay? So remember that. Now, what's left in the universal set? Well, the universal set has still 1, 2, 3, 4, 5, 6, 7's there. We got 8, 9, and 10. Okay? So there we go. An equal set. So if I was to bring this down, keeping universal set and the set A the same, then set B must have exactly the same exact elements in it. So if A has 4, 5, 6, B has to have 4, 5, 6 because these two are exactly the same. There's no difference, okay? All right, so what if we have a set with common elements? Okay, so let's say, again, I keep the universal and the A consistent. Let's make up a new B here. All right, let's say B is 1, 2, 5, and 7. Okay? So, first thing I want to do is look at what is in common between A and B. So if I ever have this, that means this part right here is what is in common between one set with the other set. In this case, set A versus set B. What do they have in common with each other? Okay? So that's what that means right there. All right? So if that's the case, let's look. I see that 5 is in common in both. So I'm going to go ahead and put 5 right there. And then what's left in red is the 4 and the 6. And the blue has 1, 2, and 7 left. Okay? So when you look at the blue, or set B, you see the 1, 2, 5, 7, right? You see all 4 of those elements that's already in there. Okay? You see that. And if you look at the red, you see the 3 elements, the 4, the 5, the 6. Okay? So you do see that as well. All right? So if you look at individual sets, you see it. But notice what's turned turned purple, right? Is where they have things in common, which is a 5. All right? Next, just so you guys know, so we know that 5 is in common, right? This is where we use the word intersect, okay? Intersect means what's in common. So intersect, the way I use it is, it's kind of like when two people meet and they want to date each other, is that because they haven't intersect with each other. They have things in common with each other, and that's what gets them interested in dating each other. Where the other side, which it would, the opposite of intersect would be a union. And we typically use the word union in marriage. So a union would be a marriage, and that would be combining all of our stuff together. Her with her stuff, her baggages, and she's taking on me and my baggages as well. Okay. Now, before I go into that, now let's talk about the universal set. What's left in the universal set if if A and B is already there, right? So 1 is taken up, 2 is taken up, 3 is not, 4 is, 5 is, 6 is, 7 is, 8 is not, 9 is not, and 10 is not. Okay, so it doesn't matter where you really put the universal set. I could just easily go, okay, so I have the 3 here, the 8 here, the 9 here, and the 10 here, right? I can easily do that as well. It doesn't have to be all clumped up in one place. It's easier to read if it's clumped up in one place, but I don't have to do that, okay? All right, so with that being said, let's now talk about the complement. The complement we talked about already is what's not there, right? So let's say, you know what? Let's do this. Let's bring down the universal set. And I'm going to go ahead and bring down this set B. Okay? So I can go through it again with you guys. And what I want to do is I want to find the complement of B, meaning not B, right? So one of the things I said to you guys was something to think about. Take the universal set, right? Which is really 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So this is equal to the universal set. So what I want to do is going, okay, so the B has a 1, so let me get rid of the 1, has a 2, so I'm going to get rid of the 2, has a 5, so I want to get rid of the 5, has a 7, so I want to get rid of the 7. Okay? So, in other words, the 1, I got rid of the 1. The 2, I got rid of the 2. The 5, I got rid of the 5. The 7, I got rid of the 7. So, in this case, what is left over here is what is not in B, right? So if you look at it, you can't find any of these elements in B at all. Okay, so that's why it's not B. That's what the complement is. Now, the intersect. All right, so, let's do, well, we talked about it here. You know what? Let's stay with this. So since we talked about it here, let's go ahead and copy that, bring it down. All right, so if I was to say, hey, I want you to find A intersect B, okay? Again, this thing right here means in common, right? What's in common, right? The intersect. So what's in common with A and B? So like we said before, I see that the 5 is in common, so this is going to give me 5. Okay? So essentially all you're looking for is exactly what is in common. So now my other question is, if that is the case, what if I had, so let me do it this way. I'm trying to think of a good way of doing this here. So let's go ahead and bring A down. And we'll go ahead and take out this, that thing there. What if I said, here's A, and I want to intersect with an empty set, right? So in other words, I'm taking A and intersecting with the empty set, all right? So intersect means what's in common. Well, if you look at the numbers here, you see 4, 5, and 6. If you look in here, what's in there? Absolutely nothing. Nothing is in there. There's no 4, there's no 5, there's no 6, there's no any other number. All right? So what do they have in common? They have absolutely nothing in common. So this would result in an empty set again. Okay? All right. So let me put a line right through here as well. All right. So with that being said, now let's get into the union. Okay? Like a marriage, right? So I'm going to go ahead and do the same thing again. Except I'm going to do... Okay, so let me go ahead and erase this here and here and this and this. I want a union now. Okay, so a union, as I said to you before, is like a marriage, right? So in other words, I am taking this and I'm putting it together with A. So everything goes, right? Everything goes. So we're literally just putting everything together. So what do I have when I union them? I'm going to have the 1, the 2, no 3 because neither of them have 3. One of them has 4, both of them has 5, one of them has 6, and one of them has 7. So 1, 2, 4, 5, 6, 7. So if you look here, you will find them either here or both. Okay? So that's what a union is the fact that you're combining everything together. Okay? You're literally taking this, you're literally taking this right here and you're putting it right in there. Okay? All right, so what if we union A and the empty set? So if I took this and saying, okay, you guys have a planned marriage and you're now together, okay? So what would I have if I did a union? Well, the union would be that the fact that they are going to be together as one. I guess the better conversation is better thing to say is now that is going to be one unit, one union, right? So that whole thing is one thing. So it has 4, it has 5, it has 6, and it also has the empty set as well. So if it has 4, 5, 6, and the empty set, that means this is going to turn out to be just 4, 5, and 6. Because we don't need to write the empty set. The empty set is always part of a set or a subset of a set and a proper subset of a set, okay? So there we go. So in the previous sample, we're saying that all of this is just going to be in one whole circle in a Venn diagram, okay? All right, so this is talking about a cardinal number of the union of two finite sets. So there's an example out there that says, okay, so the number of elements in A is equal to 490. The number of element in B is 350, okay? And then the number of elements of these two that intersect is 120, meaning they can do both A and B, right? So let's see here. So A has a total of, so the red area right here has 490. I'm just going to have to write it outside here. The blue, whoa. The blue has 350. And what they have in common is the 120. So the issue is this. I can't assume that this blue area, that not including this, that this 120 came from the 350 and this space right here should have 230. And I can't assume that this 120 came from this as well, so that this would be what, 370, right? So I can't assume that. I don't know where the 120 people in the center here came from. How many of these people came from this 350 people? And how many of these 120 people came from this whole thing? I don't know. All I know is that this circle and this circle, this circle has 490 and this circle has 350. And all I know is that this little spot right here has 120 people. All right. So in that case, when I look at this, if I want to know how many people there are all together in here in this, I guess, bow tie or whatever it's called, okay? If I want to know, then what I would do is I would add the 490 and add it to the 350. But here's the problem. If I take the 490, this gives me the whole red circle, which is 490 includes that 120 right there. And I'm adding it to the 350, and the 350 also includes that 120. So that means I counted this 120 twice, right? Once with the red, then once with the blue. So I counted it twice, so I counted 120 too many. So that's why I would subtract that 120. And when I do that, I'm going to get a total of 720. Okay? And that's what this really means. This is what this is really talking about. But if you want to remember this formula, that's certainly fine. But I think that sometimes seeing the Venn diagram is a lot easier to see for sure. All right? And so let's do some extra examples here. Okay? Let's not look at any of this. Let's just do some extra examples. Let's say, okay, let's see here. Let's say that the universal set is equal to 1, 2, 3, 4, 5, 6, and 7. Okay? And then A is equal to 1, 3, 5, and 7. And B is equal to 1, 3, 4, 5, and 6. Okay? So if you want to, you could leave it in roster method, or you could also say, you know what, I want to go ahead and draw a Venn diagram, right? So I'm just going to throw a Venn diagram here, right? But I need to erase some stuff here. I got A's and I got B's right there. So what's in common? What do they have in common here? They have 3 in common. Oh, they have 1 as well. Sorry. They have 1. They have 3. They have 5. Right? So that's what's in common in the 2. All right. So what else is A missing? A is missing a 7. And B is missing 4 and 6. Okay? So if I look at just the red right now, I see 1, 3, 5, 7. If I look at just the blue right now, I see 1, 3, 4, 5, 6. Okay? So that's good. So what is in the universal, the rest that's in the universal set that's not in A nor B? 1 is already there, 2 is not. 3 is already there, 4 is already there, 5 is already there, 6 is already there, 7 is already there. So just literally 2. 2 is the only thing that is left over. All right? So you can do it this way if you want to. Sometimes we're better at looking at this. Sometimes we're better at looking this. So if I was to tell you to look for a not A, right? Then for some of you guys, it's easier for you to see that 2, 4, 6 is not in A. Some of you guys are going to be better at looking at a list and saying, okay, I know that this is 1 through 7. I see that 2 is not here and 7 is not here. So not B is going to be 2 and 7. So some of you guys are going to be better at looking at the list to get the knots, and some of you guys are going to be better at looking at the Venn diagram and figuring out what the knots are. But however, you need to practice these just to make sure that you have it down pat and good. All right. So let's say that I continue with this and using the same sets, and I ask you what is not A union with not B. So essentially, what are you doing? You are taking, let me do this first. You're taking this A, this not A, I should say, and you're going to union with the not B, right? So if I was to union these two together, meaning they are moving into the same house, what are they going to have? They're both going to have 2. One of them has a 4, one of them has a 6, and one of them has a 7. So that is everything that's going to be in that house when they move in together. Okay? So there we go. So that is the case there. Okay, what if I said not A intersect with not B? So I'm now doing this whole thing here with a slight change of changing this to the intersect. Okay, so in other words, what's in common with the two of these sets? And you would say, what do they have in common? They only have 2 in common, right? So if that's the case, then that's it. That is done, all right? So what's going to happen is that we could have a bunch of other things that kind of come into play as well, and we need to know about that as well, right? So let's do another example, a totally different example now. Let's say that I guess I should do this part, copy. Again, new example, so don't follow that. So new example, so let's say that I'm given this Venn diagram here, but I gotta erase everything. Oopsies. Oopsies. Okay, because we gotta be able to read a Venn diagram as well. So let's say A has 3 and 6. In between, what's in common is 9 and 12. And in the B, that's not in the other one, is 15, 16, and 19. And what's left outside is 23 and 27 in this universal set. Okay? All right, so if that is the case, what is A intersect B? Meaning, what do they have in common? Right? A and B, what do they have in common? That's right, 9 and 12. Right? Because this is where these two are in common because they cross each other. Okay? Okay, how about A union B? So now I am putting this A is going to marry this. So in other words, everything in the red and blue is going. So if everything in the red and blue is going, that means I got 3, 6, 9, 12, 15, 16, and 19. All right? Well, what if I said A union B and not that? So I want not A union B. Well, if A union B is this whole thing, what's outside of this so-called bow tie? Only 23 and 27 is left there. Okay? Well, I hope. Well, actually, let's do one more. Yeah. What if I said A union not B? Let's bring this all the way over here. Right? So again, some of you guys work better in roster form, right? So let's go ahead and put this out as roster form. Right? Why not? Okay. So if I was to look at A, what's A? A was 3, 6, 9, 12. I want to union that with the B. Or not B, I'm sorry. Not B. So do we know what not B is? So maybe we need to look at what B is first. So let's come down here. Let's do this. Let's look at the universal set. That is going to be 3, 6, 9, 12, 15, 16, 19, 23, 27, right? That's everything in the universal set. B is 9, 12, 15, 16, and 19, right? So 9, 12, 15, 16, and 19. So my not B is going to be 3, 6, 23, and 27. Okay. So, with that being said, now that I can get rid of this, if I was to union these two, what would I get? They both have 3, they both have 6. One has 9, one has 12, one has 23, one has 27. Right? So, because I'm unioning them, but what if I intersected them, right? What if I took this and I intersect them instead? So meaning taking those out and changing those to intersect. Then what am I going to get? Then I need to see what they have in common. So it's 3, 6, and that's it. Right? All right. Well, I hope this really helps. Again, I think this is something new to you guys, unfamiliar to you guys. So I think it's something that you guys should really practice and just play with it and try to get a sense of it so that you know what kind of questions to ask in class. If there's any questions, let me know. Talk to you later. See you. Bye.